So let's go ahead and let's identify some positive and let's go ahead and identify a positive and negative coterminal angle for the two angles given. Let's start with the first one, which is 40 degrees. Right, we've seen 40 degrees graphed already today. Initial side is the same, and then this is going to travel up about 40 degrees, but it's definitely not going to go past 90 degrees. So there's my angle. Now I want to go ahead and find a coterminal angle. I want to find a positive and I want to find a negative. Let's start with the negative. I always find that one to be the easiest. So we're going to start here at our initial side. We're going to rotate clockwise, and I want to end up in the exact same place. And I want to end up right there. Right, so again, remember what we did in the last slide. We took this angle, right? This angle is basically 360 degrees, except in order to end up at the exact same place, I back it off just a little bit, 40 degrees. So what we're going to do to calculate our theta prime here is I'm going to take 40 degrees, right? This is a plus 40, right? That's why when I back it off that little bit, I'm adding 40, right? And then the angle in the red, it is going in the negative direction. So I'm just going to subtract 360 degrees from that. And that's going to give me a negative angle. This is going to give me a coterminal angle of negative 320 degrees. All right, let's look at another example. Now, let's say I wanted a positive one. So I'm going to start here, right? We're going to start the initial side, but now I'm going to go past it, and then I'm going to end up right at this angle, right? So this is this angle. We're going to travel 360 degrees, and then plus I'm going to travel another 40 degrees. So the way we find theta, I'll call this double prime, right? The way we find our second coterminal angle is I'm going to take 40 degrees and I'm going to add 360 degrees to it. I'm going to add 360 degrees. And that is going to give me 360. Oh, sorry, that's going to give me 400 degrees. And there we have our two answers for this first angle. Let's go ahead and look at the second example. So my second example is going to be negative 225. So for example number 2, I've got negative 225. Let's go ahead and graph this angle. So it's always going to start here at 0. This is negative 90. This is well, let's not even cross it out. This is negative 180. This is negative 270, and then coming back, and this is going to be negative 360. So negative 225, I know I'm going to go negative 90, negative 180, and it's not going to go past negative 270. So we're going to end up somewhere in here. So I want to find two coterminal angles. Let's go ahead and let's find a positive coterminal angle. So one way I can do it is I can just start here at my initial side. I can go counterclockwise and then end up at that same angle. So the way I'm going to find theta is we're always going to start with our angle, right? In this case, we're going to start with negative 225 degrees. Let's go ahead and move this. I'm going to need a little bit more space. Let's put it down here. So I know that my theta prime is going to be equal to negative 225, and then I'm going to add 360 to it. See, notice that pattern. I'm going to add 360 degrees to it. And that'll give me, let's calculate that. So negative 225 plus 360, that'll give me a positive 135 degrees. And that makes sense, right? It's in the second quadrant, which is in between positive 90 and positive 180. Let's find a second angle, but let's make this one negative. So I'm going to travel the negative direction. I'm going to pass that angle once, and I'm going to go all the way back around and end up there. So remember that this is going to be negative 360 plus that negative 225 degrees. So my theta double prime, so theta double prime is equal to that negative 225, and then since I'm going in the negative direction, minus 360 degrees. And now that's going to give me negative 585. So for our third objective, we're going to convert between degrees and radians. In this slide, I'm going to just quickly introduce what a radian is. So a radian is going to be another way to measure an angle, and it's based off the length of the radius. So the definition is that if I were to take the arc length of a circle, so this piece right here, let's highlight it. This piece right here is the measure of an arc of a circle. All right, that's a piece of a whole circle, right? I can continue drawing the whole circle, something like that. All right, so that's what an arc is. So whenever the arc measure, so whenever this measure right here, the arc, has the exact same value as, or the exact same length as the radius of the circle, then we know that the angle measurement between the angle is going to be 1 radian. Okay, so whenever the arc length is equal to the radius, that gives me 1 radian. So I can draw another arc measure of r, right? Let's say this is also equal to the measure of the radius. Then I have another radian. Then this measure is 1 radian. I can continue going. I can go another measure of the radius, and I can get a third radian. So the benefits of using radians is just like degrees, no matter what size the circle is, the radian measure is going to be the same. The most important one, though, is that there are no units, right? Degrees has a unit, has a degree unit, whereas the radian, it doesn't. So that makes it really nice when we're solving problems. So in this lesson, we're going to convert between angles and radians. So let's go ahead and start off with the formula, and we're going to learn a little bit later why the formula is the way it is. So in this first row, we're going to be going from angles to radians. So angles we always denote as theta, and in order for me to get this to become a radian, then I'm going to have to multiply it by the conversion factor of pi over 180 degrees. Theta is an angle in degrees, so that's why the 180 degrees is in the denominator, because those angles are going to cancel out and leave us with just radians. So let's look at an example of that. So our example is going to be, let's look at 120 degrees, right? This is my angle measurement, and I'm going to multiply that by the conversion factor pi over 180. Now what you want to do here is you're going to want to simplify the fraction. So I'm going to write a little note. Simplify the fractions. Okay, whenever we're going from angles to radians, we're going to want to simplify those fractions. So I'll leave that note off to the side. So let's go ahead and do that. I'm gonna multiply straight across. Let's put a 1 under here. I'm going to multiply straight across to end up with 120 pi over 180. And then I'm going to look to simplify. I can divide both by 10, so getting rid of the zeros. And then let's go ahead and look for another way to simplify 12 and 18. Well, both can be divided by 6, right? I can divide 12 by 6, and I can divide 18 by 6 as well. And that would leave me with 12 divided by 6 is 2, and I'm left with the pi over 18 divided by 6, which is 3. and now I have the equivalent radian. Now let's go ahead and let's convert radians to angles. So my rule here is that if I'm given a radian, so it's typically radians are denoted by x, then I'm going to multiply it by the conversion factor 180 over pi. So notice how it is very similar to the conversion factor of angles to radians. It is just a reciprocal. So the reason why I have pi in the denominator is because I want the pi to cancel out with the pi in the radian. So let's see how that's going to look, right? So I have my negative 3 pi over 8. And I'm going to multiply that by my conversion factor, which is 180 over pi, because I want the pi's to cancel out. And then I'm going to look to cross cancel, see if I can cross cancel anything. 8 and 18, they're both even, so let's see if they can be divided by 4. Yes, they can. So I'm going to divide them both by 4. Whoops, not 40. I'm divide them both by 4, so it'll make my life a little bit easier. So this is going to become negative 3 pi over 2, and then times, this is going to become 45 over, oh, I'm sorry, the pi's got canceled, so no more pi, pi. And then negative, or just, I'm sorry, 45 over just 1, right, since the pi canceled out. And now we can just multiply straight across. So negative 3 times 45, that gives me negative 135. And then 2 times 1 gives me 2. Let's go ahead and divide that out, and I end up with negative 67.5 degrees. So our rule for the radians is going to be, so for radians, we are going to want to cancel out the pi. Cancel out the pi. Then simplify and multiply out. All right, so that's exactly what we did, right? We canceled out the pi's. Then I simplified the 8 and the 180, and then I just multiplied straight across and divided.